All right. So in today's session, we are going to cover text mining and text processing. Usually, this text mining is used in research when we are curating data sets. One of the example I would give from my field is if we are trying to find out the function of a gene or the pathways certain genes are in literature. If we are curating literature, then what we do is accumulate all the content of literature into text files and try to process those. It's highly unlikely for somebody to read through, say, 50 pages of worth of data in order to find out the what a gene's likely function is. For these are for new genes, not for established genes. There are already databases, but for new genes, if you don't know the function, you're still trying to and find out, and research is still ongoing for genes like those. We try to collect literature and try within literature. We try to scan to see if what is the consensus function of the gene. That's just one example. But in um, in data science, what you do is if you want to try to suppose there is a new phone that came out and you want to analyze the sentiment of the masses of what they think about the phone or a feature or a new website or things like that, what we do is we collect relevant files from say social media, Twitter, and other social media sites, and we accumulate them as flat files and then try to find out what words are frequently occurring, if they are positive words or negative words, depending on a database that they have already of positive and negative words. They try to analyze the sentiment of a feature or a phone or anything new that they want to see what market's reaction is. So that's one example on the data science side of things where they use text mining, and of course there are lots of others that you can use text mining for. So let's just quickly dive into what we are going to do today. So for most of these packages, your version of R should be 3.3.1. So how will you know that? In your RStudio, once you open, you have this on your console, you have this R version, and each R version has a name. So mine is 3.3.2 and its name is Sincere Pumpkin Patch. But if you want to upgrade your R, you could go here and look at global options. It's not mine is slow. Okay, so here global options, you see that there is R and then there are versions. If you want to change the versions, you go here, and I had several of previous versions, so I changed it here. But to get the latest upgraded R, you'll have to download it from our website and then use that to use the latest version. So I have multiple versions here because some of my packages work only with older versions of R. So then I switch between these to use an older version of R. But for today's packages to work, you should have at least a 3.3.1, and then try installing. If you have any trouble installing the packages that I sent you in the email, you first have to, then it's probably your R, you first have to upgrade your R and then reinstall those packages. Okay, so some of these packages, like this package called rGraphviz, is not from the regular CRAN site. It's from a bioconductor repository. A bioconductor is a group of R packages which are specifically used in machine learning, data science, and some of more for biological applications. So, Bioconductor is one such repository. So this one, if you want to install rviz or any packages from the Bioconductor package, this is what you have to do. You'll have to first source the Bioconductor website and an R script from that, and then use this command bioclite and use the Bioconductor package. Okay, so let's get started. So first of all, in my folder, I have 6 different files, and when I made these slides were made very way back when I was trying to work with longer text files, but just to duplicate and show you an example, I had taken Wikipedia output and some other outputs from the internet, just taken those and copy pasted them in a text file. And if you see, I have some Wikipedia notes and some notes from some other websites. So you could make files like these on any one topic, one of your favorite topic. I did it on quantitative research, and I put in content from different websites into these 6 files. If you are interested in some other files, you could very well use those. But just for example, I have these files. I can send these to you after the class, and you can experiment on these and try to replicate what I did in the class. Or you could use some other text files. Just use any topic of your interest, type in the internet, and gather a few, just copy paste some of the matter from websites into text files to make your batch of text files to mine. So first, we are using a library called TM, which stands for text mining. It's a text mining package. And first of all, what you do is you specify where your files lie. So I have this line here, which specifies the file path. When I made these slides, I was working on Mac, so I have the path here relative to Mac files, where if I give whatever signs I give within the method file.path, it's going to create a path from this. So whatever I give it here, so I gave here tilde, a desktop, and text. So it's going to concatenate all the terms that I give within the file.path and make a path like this. So I'm assigning that to CNAME, and CNAME is going to be this desktop text. So similarly, what you can do in Windows, whatever you have, just put those texts over here, or more simply, you could just put in the directory, the forward or backward slash. So again, be careful with your Windows, because I have this example over here. Be careful with your Windows, because forward slash and backward slash is kind of confusing in Windows. So always, I believe you're still doing this, setting your working directory and making sure that R knows where your files are. So just as an example, I have this one over here, which is setting my directory. So let's just check before you even set your directory. Let's just check where the working directory is. So you do get wd to see the working directory. It's in documents, which is not where I want to be. So I'm going to set it to where my text files are. So now I'm going to load the package. So it says it's actually the package TM is built under version 3.3.3 and minus 3.3.2. So sometimes if you get errors, make sure all your packages are up to date. But I don't think it's a problem with mine. So if there is a problem, then I'll have to go back and upload it. But for now, let's do this. So just to mimic what I have on the slides, I have this file.path and I have two other directory names. So just to show you what it's going to, what file.path is going to do, whatever directory names you give it, it's just going to concatenate it with a / which stands for inner directories. So once you have the directory name fully, now if you use the method called dir, dir, and give it a path, it's going to list all the files in that particular folder. So what I'm doing is I'm going to this path and asking it to list all the files in that directory. So R is listing these files, which are the 6 text files that I put in the folder. So you can check that with the dir command. Now, after this, we are going into a series of other class objects. So until now, we have looked at all the other data structures like list, matrix, data frames, and vectors and such. So from now on, from today's class onwards, we are going to deal with objects of various other classes. So why you would ask, look, what is the need for objects to be in other classes when there are lists and data frames and other data structures? So usually when people build packages, what they do is they want the data to be in a certain format for all their methods to work. So that is the reason why and this TM was built by some person, and for all his methods in the TM package to work, it has to be in a certain format. So we'll have to make sure that our data is in a certain format. And what we are going to bring that format in is by using this function called corpus and dir source. So what it's going to do is it's going to put the files in that particular folder, which are these 6 text files, into a format and into an object of the corpus class. You may ask what the corpus class is and what those are. It's a particular data format where we are storing all these text files, all these 6 text files in an easy to use format within R, in a binary format. So we could run functions and many other methods on all of these text files, or even if you have 100, say, even if you have 100, this corpus class is going to put them in a good, nice tree format where you can run multiple functions on all of those 100 files. So again, if you have any doubts with methods, you know where to go. Go to help and type corpus. So the help window pops up, and corpus belongs to the TM, which is the text mining package. It's representing and computing on Corpora. It's a collection of documents, as I just told you, in containing natural language text. So it's a class where you could easily store a lot of documents which have natural language text. So what does this do? So I run this package, this line of code, and it's putting all the files, all the 6 text files I have in the folder in a particular format. And if we want to check the class of docs now, it's going to be whatever object that has been generated. So this is the class, simple corpus corpus. You don't have to really know what the meaning of that is. For now, you just have to know that it is simply a collection of all the files put in one simple object and one simple structure to be able to run all the other methods from the TM package. So what you could do is you could run a method called summary of the docs. So as you see, if you run this method called summary on the corpus object docs, you will see what all it has. It has all these text files 1, 2, 3, 4, 5, 6. It has the length. Length doesn't really mean anything. It's probably the length of the number of words or in the number of words it contains. So it's like wiki output 1 and text. And the class, all these are plain text documents, and therefore the class is a plain text document and its mode is a list. So if you remember this basically docs is a list of lists. So how do you access a list with this double square brackets, right? So if you do docs of 1, then you will get access. It's a pointer to the very first document, and so you will have these documents up to 6 because there are 6 files, right? We'll try to do 7 and see here, and it says out of bound. So since the 6 files are put in this docs class and this object, you can access it through the double square brackets, which is the way you would access lists. So any questions until now? All right. So let's go back to our slides. Okay, so even before pre-processing, I wanted to show you something else. Okay, now I showed you how to access the pointers to these documents. How do you read the contents of these documents? So depending on the size of your documents, excuse me, depending on the size of your documents, you can use a function called inspect. And you can use, say, the first document, and it's going to display the contents of that document. So depending on the size of the document, you may decide if you want to display it or not. Sometimes it's just going to truncate it, and it's going to truncate it, or it's going to freeze your console trying to print it if you have like a very, very long document. So depending on that, you may want to choose to use this, or I don't know if head will work on this. So let's try head. Let's try head on this and see. Okay, so head is giving you a truncated version, and it's giving you some of the content, but with these special characters of new line or a tab, or depending on what your document actually has. So that's the way to inspect what the contents of your documents are. And next thing is we want to go back to our slides. So what is our objective today? So from these text files, from the 6 text files I have here, what I want to do is I want to see what frequency of words come up more frequently. So suppose I have a word here saying interpreter that comes up very frequently in all these six documents, then that's what it is about. That's what those files are about. Or say the word criticism comes up more frequently, then it says something about the kind of content we have in those documents. So that's what I'm trying to do. I'm trying to get most frequently occurring words here from all these six documents. So in order to do that, we have to first pre-process your data. So we have a lot of noise in the data that we don't want to count, right? Something like you don't want to count punctuations, like the quotes or a full stop, a comma. You don't want to count those, and you don't want to count special characters. Maybe there is a semicolon, a colon, so those come under punctuations. But if there is an at the rate symbol, if there is a dollar, you don't want to count those too, because those do not make any sense. You want to be able to count words which have excuse me, you want to be able to count words that have some meaning, and they actually project something about what your documents have, or how what your documents talks about the content. Some talk something about the content in your documents. So you want to remove all special characters. You want to remove any numbers. So any numbers, they do not really make sense, because having numbers in your documents doesn't, if that is what you want to count, you could, if you could keep them, but most likely when we are trying to analyze what's in the document, you remove numbers. And you want to make everything lowercase, because R treats R is case sensitive, and R treats a capitalized word differently than everything in lowercase. So convert everything to lowercase. You want to remove stop words such as articles or vowels or consonants, or merging concatenation words, something like a and the, also, etc. And they have a lot of there are a lot of other prepositions and things that you use to concatenate and make sentences. So those are something that you want to remove too. Otherwise, the most frequent word that's showing up in your documents may be the, right? So those do not make sense when you're trying to get to the most frequently used words or the meaning in the content of these documents. And so depending on whether you want to do this or no, depending upon the nature of your documents, you may remove some of the common endings like ing, is, s, etc. And these are called stemming in the document. So you want to maybe remove containing. So the present tense, past tense, the plural forms, and you may want to remove all those. And then this is something very common in most documents, that you want to strip any unnecessary white space, because the first thing is it's making your document concise and short, and each step you follow through in your pre-processing will make your documents shorter and easy to handle, and it will be truncating the unnecessary words and characters from your documents to get to the most important meat of your document. So you may strip off all the white spaces, and then you tell if during the process the documents are converted into something else, or initially you're starting with something else, you may want to convert it to a text document. So these are the steps that you use, and for most of the removing and pre-processing, we use this function called tm_map, which is a function which would transform your documents and remove remove most of the punctuations and numbers and conversions, just to transform all your documents into using all the pre-processing steps that we want to make sure your document just has the most important relevant words. So just to go through these in your example in the RStudio, I have some steps here. I'm not using every step in this, but I'm going to show you a few things, and I'm going to point out to one interesting piece here, which is this for loop. So this tm_map, which is a method within the tm class. Again, if you want to go through the details of each method. So whenever you start using a new package, right, nobody will ever know what and how the package functions. So we use tons of packages every week, and there is some person or a group writing it, and they will have their own nomenclature and their way of defining methods. So nobody will ever know right off the bat how and what functions to use. It only comes from digging more into that package. So once you start with your new package, you have to go to the TM package, or the in the help, and try to look up those packages. So if you type the TM package, this is the text mining package, and if you open this up, text mining, it actually shows you a description of all the methods it has. So, and depending on what you want, that's where you go to. So this is what we are using, tm_map. So usually, how do you even know which package to use? So for particular functions, the most frequently used packages or the most popular ones will be in the internet. So pretty much internet search, to suppose if you want to do text mining, just do packages for text mining in R, and then you will get to a list of most popular packages, and you will have to just download, install that in your RStudio, and start experimenting with some of these functions. And to know the usage, you go to this examples part of the documentation, and you run these and see if that is what you really want to do. So most of the times, the description here is pretty handy, and if you look at the description for the package, you will get a sense of what package it is and what it does. So you really don't have to know all the methods and what they use, but you have to be clear on the one or two steps or the 1-2 functions that you want to achieve using that package, and just focus on those methods. So for this pre-processing, we are using the tm_map method. So if you want to go through that method, type in your help and see what that method is. It's just a transformation method where it takes in an object of the corpus class, and it takes in a function, and then it runs this function on each one of those documents. So remember, this docs corpus class has my six documents I had in the folder. So right now I am running a function called remove punctuation. Remove punctuation is already an inbuilt function from the package. I don't remember. Okay, so it is also in the TM text mining package. So we use that function to be run on each of these 6 documents in the docs structure. Okay, so once you run this, you will have to make sure all the punctuations are removed. So just inspect just the top or just one document. from these and make sure that punctuations are removed. And I see some apostrophes still here. Yeah, other than that, I think all the full stops are removed. Right. So all the full stops are removed. And let's see. So the second processing step that I run is remove numbers. So now I remove numbers and assign it to the same word again, docs. And let's now inspect and see whether all my numbers are gone. Yes, so I had all these numbers for all these, and so that's gone. So now I'm converting all the capitalized letters to lowercase letters. So all these capitalizations should go away. So let's check that. So usually it's a good practice to check after each step whether your desired thing is being run or not. Most times it will be, but if there are typos, then maybe you're looking at the wrong output or there is a typo in the output that you're looking. So it's usually good to look after each step just to make sure that it's that particular operation is being done. So you see here all the capitalized words are turned into lowercase letters, and now I'm using the same TM underscore map to remove stop words. So again, remove words is a function in the TM package, and it removes, it takes in one parameter called stop words, and you can give it certain arguments within the stop word. So I'm giving it English and I'm calling it, and I am using the stop words, which is going to remove all my ands, buts, and uhs and thus. So let's see. Yeah, so now it's going to look, yeah, even more like a bunch of words because all the concatenating vowels and consonants and prepositions and articles are gone. So now I am going to remove the stemming, which is the ending in ing and like continuous tenses and singular plurals, just removing all the plurals. It's going to, my document is going to look weird, but that is what I want to be able to get to the words. So you will notice like some of the things that like this was qualitative research and it just removed ative and psychology. I think it's psychological, so that's why it removed ICAL. So it's going to remove most of your ending words, disciplinarian background. So it removed that. So it removes most of your ending letters to make words, and this is the best it could do. And the next step, I'm going to remove my white spaces. So I'm going to strip all the white space. Yeah, and if you recollect, I had like a bunch of, these are all the starting ones were in different lines, so it stripped away all the white space. And you have to be careful when you're turning into a plain text document, and even from if you're following the steps from these slides, you have to be very careful when you run this step, because if it's already a plain text and you try to reconvert it to a plain text, the next stage is not going to run. It's going to give you an error. So first, check your class of the documents, not the documents, of the one first document. And you see that it's a text document. So I do not require the step of converting it into a plain text document. All right, so now that all my pre-processing is done, I have removed all the punctuations, numbers, converted everything to lowercase letters and use. Suppose if you have any special characters and you want to remove those, we don't have a function for removing special characters. So you will have to use an inbuilt R function called gsub. Gsub is used for substituting any character with some other character. So why am I doing a for loop here? Anybody, any guesses? Why am I doing for loop? I could just use the tm underscore map. Why am I doing a for loop over here? Any guesses, anybody? For using the gsub to repeat on all docs, correct? Yes, that's correct. But it is to repeat on all docs, but the tm underscore map is also running on all the docs. But so it is a list, yes, correct. Because my gsub will run only on a bunch of text or a string, and that is why I am having to run it on each of the documents. And I cannot use this because if I give this a gsub over here, it's not going to run. My gsub will not run on the list of documents. It runs only on a bunch of text. So for gsub, you will have to extract that text and pass it. So what I'm doing here is replacing some special characters like /, symbol, /, and just a partition with empty space. So for gsub is a method where the first argument you want to give is the symbol that you want to replace or a substring that you want to replace, and the second argument is what you want to replace with, and the third argument is in what the text you want to use to make this replacements. So here I'm replacing all the / in this text with a empty white space, and all the @ signs with an empty white text, and all the / with an empty white text. And I do it on each doc, and this is the way you can iterate through the number of docs. Basically, seek, if you remember from our very first sessions, will give us a sequence of the number of documents. So this seek of docs is going to give me 1 to 6 numbers, and therefore a J will contain 1 to 6, and as each iteration goes on, it will access and do these replacements for every document in those 6 documents. And so I have this, and if you have to replace particular words, I have these. You could do it this way. If you want to replace particular words, like if you don't want qualitative research, qualitative studies, all that with abbreviations. So you could do these, and if you want to totally remove certain words, like you don't need department and email, then you could use the tm underscore map. You could use the remove words as I used over here, and I'm using stop words here, but you could give it within as a list the bunch of words that you don't want to show up in the frequent words. So you could do these two, but I am not doing that in my code here. I am directly going to our next stage, which is called staging of a document. So how do you stage the data? So what is the meaning of staging? What we need now is we have a bunch of text. We have stripped away all the unnecessary information that we don't need. We stripped away the endings. We stripped away white spaces, prepositions, articles, all unnecessary words, and now we have just the words that we need or that we think are representative of the meaning of the documents. So what we are going to do now, what we need now, if you had just one single paragraph of 5 lines and you want to calculate the frequency of the words occurring in that paragraph, what would you do? You would take a matrix, or you would write it down as a table, and say just count the word one and say see how many times that word one occurs in that paragraph. So we want those two matrices. So for that, what we use is from the same TM package, we use these two methods. It's called document term matrix and term document matrix. So it's only these two matrices are a reverse of themselves. It's like a transpose of the same, where all the documents are taken, they are broken down into their representative words, and a frequency of the number of words occurring in the documents is calculated. So I'm just going to show you these two steps now. So I have this document term matrix. I'm going to run this and see what my DTM looks like. So it's saying it has 6 documents and 1,361 terms within those 6 documents. And it's giving certain measures like there are non-sparse and sparse entries. So what do you mean by non-sparse and sparse entries? Sparse means the term is occurring just once in one document and it doesn't show up in any other document. So that is called sparsity. And you see that there is a measure for the sparsity. It's 69%. That means in your matrix of document and the words, the matrix is 69% sparse, meaning you see one word in one document only once, or you see it in maybe 2 documents and not others, something like that. So it means that you will see the words very sparsely across the documents, and you have this length, you have the term frequency. And similarly for the term document matrix, which is just a transposition of the previous matrix, you will see that it is similar to, it's just the matrix now, the rows will be the terms and the columns will be the document names. So the previous one, you have the rows as the document names and the columns as the terms occurring in those documents. So it's just a transpose of the two. I will be using just the first one, but I just showed you in case you want it in a different way. So now we don't want our matrix. So this was a matrix that I was talking about. You have in the documents, you have these terms, which is I have here different terms because I was using different text files then. So there are terms that are occurring in the documents, and you will see those terms occurring the number of times. So we will inspect this right now, but let's remove some sparse terms. So let's just inspect one of this and see. Let's just inspect the DTM, and this is what you'll see. You have 1361 of these terms, but it's going to display just a few over here, and you will have all these the documents names over here, and it's going to give you a tally of these words occurring in each of these documents, number of times these words occur in each of these documents. Okay, since I had research for qualitative research, the qualitative, if I hadn't removed the STEM words or the STEM document, if I hadn't done that, it would have been qualitative research. And so since my whole search was that, you will see that the more frequency of these two words, qualitative research words occurring, and you see that data comes up more frequently. That's just a glance of the first few words. And what we do is we don't want this matrix. And as this matrix continues, you will see more sparser words, meaning you will have certain words that appear in only one of these documents, and you will see maybe zeros in many others, and just maybe a very low number in one of these documents. So that's what I mean by sparsity. So you don't want you don't want your matrix to be sparse. You want it to be dense. You want it to represent the words coming from all these documents. So what we do is we use this method called remove sparse terms, and you will have to give it the document term matrix. And again, this has to be a DTM type of class object, and then you give it a certain number. So here what you're saying is, I want to have only 10% of my matrix empty, meaning if I have if I have all zeros and just one of these having numbers, that term will be removed. So we'll remove all the sparse terms using this, and then we will take a look at, we will inspect this and see what it turns. So since this is displaying just the most frequently used words, but what you will see here is you will see this. This will be different from what you have seen before, where you will see the non-sparse to sparse entries is 2,516 and 5,000 something. And here you will see that the sparse entries have gone and the sparsity is 0. So this is one way of processing your data to remove the sparse elements. And now you want to calculate how many times each of these occurs. So now we don't want to look at the number, each of these documents and how many times it occurs. We just want a total of these words occurring in all the documents. And so we could use a method called call sums, which calculates a tally of this word occurring in all the documents. So we'll use something called as call sums. Do I have it here? Removing sparsity. Yes, I have it here. So we'll use a method called as call sums, which calculates the sums of each column. And again, you will have to convert this DTMS type of class object to a matrix, because call sums is something that works on a matrix. How will you know all this? As you keep practicing, the more and more these things will get clear. So you'll have to convert this DTMS, which is a document term matrix class, into a matrix. So you'll have to convert that into a matrix and then use column sums. So what will this return? So let's see what Freak has. So it has all the all the terms occurring, and it's just the tally of the sum or the number of times this particular word occurred in all these 6 documents. So here you'll find the highest, I think, is this one, which is not uncommon because it's the whole, oh, or this one, which is not uncommon because it's my whole search was based on qualitative research. So that will be the frequency of all these terms. And since my documents are small enough, it has given me only a few of these terms, but depending on the size of your documents and the number of documents you may have, there will be hundreds of these terms and you will get frequency for each of these terms. And so you will have to have a way to interact and look at these terms, and you certainly have some of these inbuilt functions working on this. So you can create a table of these frequency. Table function is not something new. You already know this. You just get a frequency of the total number of words and just the top 20 words and things like that. So you can use head, you can use tail, you can create tables of these, and you can see how many words are there in total, and you can see how many times each word is repeated across the files and similar things like these. So go through this one to see if to be able to access these frequency of words. And similarly, since this freak is a column sums, so you could access it as an array or a vector, and you could give it with ordered list from you could use the tail and give it an ordered list, which is going to order it of the last few or the last 6, and you could give it as head. It's going to be the first. So there are different ways you can interact with these terms, and this is one way where we try to display the top or the words which occurred at least 50 times over across all your documents. So you could use a function called find freak terms. All these functions are in the TM package, and you could pass it the matrix, the data term matrix, and you could give it a threshold for the number of times you'll have to see that word in across all these documents. So there are multiple ways of looking at it. So now, using those, you can also plot the frequencies. So what you're doing here, I previously did not go through this library, but this is a library called ggplot2. It is a library for making prettier plots. In the past, we used plot, but I just wanted to introduce you to this package more and more because more and more just research style or literature style plots are made using this package, ggplot2. So we use this package, and what we do is we create a data frame of the names or the words of the frequency, and we create a frequency data frame. So let's see what this data frame looks like. It's just a reversed version of what you see over here. It's just going to have the names or the words as the rows and the number of times it occurred as the columns. So let's just look at that one. I'll have to load my ggplot2. I will create a data frame and look at what this data frame looks like. This is the word frequency. As I told you, it's going to have the words and the number of times it occurred. And I am going to plot this. So now you should get used to this type of plotting, because this is the way ggplot does plotting. You will have to pass it first a data set, and don't be intimidated by or the use of all these functions for a data set, but is basically a data set. You pass it a data set, and using this method, you will specify what the x and y should look like. So I'm putting on the x-axis, I'm putting the words, and the y-axis, I'm putting the frequency. And ggplot is a kind of cumbersome looking code where you'll have to store this into an object, and then you add upon that to build each and every element of the plot. So you should to give it a bar plot. To make it a bar plot, you do this geom underscore bar, and then you pass it identity is use those numbers as it is. Okay, so if you run this, you will see my plot here. As I told you, on the x-axis we have the words, and on the y-axis is the frequency or the number of times it's occurring. So right off the bat, you see that the word research is the highest occurring word, having like 250, crossing 250 times it occurs over 6 documents. So you could create plots like this. And the next thing you could do, cool thing, is create a word cloud. So what is this word cloud? It's just a representation of the number of words that are occurring based on the frequency or the times, the number of times they occur. So this is, so let me just run this. So this is what you will get. It's going to display, as we just saw in the bar plot, the research is the word that is displayed highest number of times. So the size of research will be much bigger than the others, which are much smaller. Depending on how many times they occur, the size will depend on that. And we could so each time I run this, it's going to look slightly different. You see the orientation of research is like this, and everything else is jumbled. So every time I run this, it's going to look slightly different. But if you want it to look the same, you'll have to use this this method called set.seed and run these together. If you run these together, every time it's going to look the same. So you'll have to set seed and use that same seed to be able to reproduce that plot in exact same format. So again, you can do a lot of cool things with these clouds. You can give it colors, and you can set a panel using a Brewer panel palette, and you can specify different color schemes for these colors and these word clouds. So the next piece, I want to take a few more minutes just to finish up this last piece, which is called hierarchical clustering. So what we do is within words, or within, say, use any biological example, we calculate between these. So since we are talking just about words in a text file, let's just stick to that example. So within these words, some of these words are more relevant to each other compared to others. Like research always goes with data and studies and observations, rather than social or techniques, or just the distance between these words is much further. So we calculate something called distance, and we can see how these words cluster within say a text. So we calculate something called a Euclidean distance, which calculates just based on where these words are occurring, in how many sentences they are occurring, or how close they are to each other. Just based on that, there is a calculation and a measure of distance between these words, and that's what you get by using the dist function. You calculate a Euclidean distance between the words, and this is somewhat unreadable, but it's basically calculates the distance between every word to every other word in terms of how close or far they occur within the text. And if you do a clustering based on If you do a clustering based on the distances, you will have to use this hclust method to create a cluster, a fit, and you will be able to plot these fit in a form of a clusterogram. So this is a clusterogram or a dendrogram as it is called. So here you will observe how these words are grouped. So here you will observe that research, quality, data and observations are in one group, which is much far away from the other set of groups. Like, there's one cluster over here and you see one cluster over here. Just to see the link between these various words that are occurring. And so the other thing that you could do is, this is just hierarchical clustering. Hierarchical clustering, you can look up what it means. It just means that you are kind of drawing patterns within your data. You're kind of trying to see how these different words cluster and are related to each other, just trying to discover links between these words. So and to be able to distinguish between the various groups, there are other ways of highlighting certain groups using these methods over here called rect hclust, and you can draw a border around this and name. So here I'm naming 5 clusters. So I'm asking to form 5 clusters, identify 5 clusters with a red border. So it drew a red border around the 5 clusters. So depending on how many clusters you need, say if you just wanted 2 clusters, then it's probably going to draw data as one cluster and all these as another cluster, depending on the distance between them. You see that there is a line going from here. Data is very different from this huge cluster. So depending on the number of clusters you want to see, it's going to highlight those colors. Just going to highlight with a border around those clusters. So this is one of the clustering scheme that is pretty much used very often in gene expression, or mostly, I'm talking about biological terms, but even in the social networking, to predict links and friends of friends. How does Facebook suggest friends or people you may know, depending on what links and how you and based on what you post, and based on your profile and things like that. So there is another means of clustering called k-means clustering. You don't have to go into the details of how it's done, but it's basically depending on the center, or the center of each group. Distances are measured of these individual words. So you could plot these k-means clustering in a form like this using the clustplot method. And here also, since I wanted to see just 2 groups, you see the blue group and the red group. Here also it pretty much predicts the same thing as data linked to the others, like quality analysis, participation or participant, and research, and the other words forming into one other cluster. So these are different ways of clustering, forming patterns, seeing patterns within your data, and very useful in networking, social networking, sentiment analysis, Twitter for Twitter feeds processing, and also gene expression, biological pathway analysis. So that's pretty much it for today. So sorry for running over a little. And whenever you get a chance, just practice all these. I'm going to send you the slides after the class. So any questions?